In this video with polynomials, we're going to look at the degree of a polynomial. Now, what you need to know is the degree of polynomial is a new term, but not really a new concept. You've been dealing with degrees in the past. It's just now we're looking at that the degree relates to the exponent. Now, you can't say those two words are exactly interchangeable, but they are to a sense. The degree of a polynomial is the largest exponent of the variable for it. The degree determines the type of polynomial, whether it's going to be linear, quadratic, cubic, quartic, or quintic, and the number of possible real zeros, not the guaranteed real zeros, but the possible amount it can have. And remember, we learned in chapter 5 that zeros represent where the graph crosses the x-axis. They represent the x-intercepts. And so we're going to take this idea that to determine the degree of a polynomial, we need to figure out what the largest exponent of the variable is. That's going to tell us the shape of the graph, which tells us the type of polynomial and the number of real zeros. So let's take a look at these two examples. Determine the type, the degree, and the number of possible real zeros of the polynomials given. So first we have 6x to the fourth minus 3x cubed plus 4x minus 9. So I'm going to take a look. I'm going to start with the degree because the degree is the largest exponent of my variable, which is 4. Now, what's nice about starting with the degree is it allows me to know the type of polynomial given. Remember, 4 for the degree means you're going to have a possible number of 4 real zeros, 4 x-intercepts, which means it is a quartic polynomial. If we look at the next one, x to the fifth plus 2x cubed plus 4x minus 9, looking at my exponents for my variable, 5 is the largest one. So my degree is 5, which means I'm going to have a possible number of 5 real zeros. 5 x-intercepts are my possibilities. And the type, well, if you have 5 zeros, a chance of 5 x-intercepts, a degree of 5, that is what we call a quintic polynomial. So what do you notice so far? You notice, and this was in the definition, your degree of the polynomial is going to be the same as the possible real zeros. And that's in our definition of the degree. The degree determines the type of polynomial and the number of real zeros. So the degree and the possible real zeros are going to be the exact same number. And the degree tells us what type of polynomial we are dealing with.